So I think we're all familiar with the idea of finding the sum of the interior angles of a polygon. And we'll have a look at this first one. This is a pentagon. It's got 5 sides, let's just count them. 1, 2, 3, 4, 5 vertices and 1, 2, 3, 4, 5 sides. And so the usual procedure is to start at any vertex and connect to the other vertices. And you can see that you've created 1, 2, 3 triangles. And if you think about the sum of the angles of this triangle, that would be 180. And then if you think of the sum of the angles of this triangle, that's also 180. And finally, the sum of the angles in this triangle, that's also 180. So therefore, the sum of the interior angles, can you see we've covered them all now, because that makes the interior angle. This is the second interior angle, the third, the fourth and the fifth. So that's pretty much covered by 3 times the 180 to give 540. And that's absolutely sound technique, right? I suppose the only problem with that idea, and I think it generalizes right to n minus 2 lots of 180, and I think we've seen that formula before. We can generalize to any n-sided polygon. But there is a problem, right? If you have a look at the shape at the bottom, let's just see what type of shape it is. 1, 2, 3, 4, 5, 6. This is a 6-sided shape, 6-sided polygon. 1, 2, 3, 4, 5, 6, right? 6 vertices, 6 edges. This becomes a little bit more problematic because if we start at one of the vertices now, I'll start at this one, and if we connect to the other vertices, that becomes more complicated, right? So let me just undo that. I think for this one we have to choose very carefully, right, how we connect. Maybe this vertex first. That seems to have done it, right? And now we can still employ the same technique. There's one triangle. Yeah, I can see it now, right? So we can do 1, 2, 3, 4 triangles, 4 times 180, which is 720. Okay, so that still works, right? 6 minus 2 times 180. So that's great, okay? But I do like another technique, and so I want to share this with you. Place a dot somewhere inside, and now connect that dot to all the vertices. Okay, so now let's have a little look. These are the same shapes. So this is n equals 5. It's a pentagon. And just have a look at how many triangles we've created. Can you see? 1, 2, 3, 4, 5 triangles. So that would be 5 times the 180. But let's go and check to see if that gives us what we want. So the 180 for this guy would be here. The 180 for this triangle would be here. And the 180 for this triangle, 180 would be all of those angles added together. And 180 for all these angles added together. And the final 180 for all these angles added together. Now, can you see the problem with 5 times 180? That doesn't get us the sum of all the interior angles, which are these ones. It also gives us all of this. But how much is all of this? We subtract 360. Now let's take that for a test drive. That's 900 minus 360, which is indeed 540, which is the correct answer. And I quite like it for this one as well, because we're going to get the same result here, no matter what weirdness we get. That will be 1, 2, 3, 4, 5, 6. 6 triangles, because it's a hexagon, 6 sides. But then we subtract the 360. So I like this formula that is for an n-sided polygon, it's 180 times by n, but subtract the 360 in the middle. And we can compare that with n minus 2 times 180 from before. And of course, you may have seen the connection, right? Because these are identical expressions. We can factorize by taking out a factor of 180, and this will be n minus 2. And you can now see the equivalence between the two formulas. They're absolutely equivalent, right? So I don't know, I quite like this formula because I can see that the n appears exactly for the 6-sided polygon and the n is the 5-sided polygon. If you use this formula, that's just as good, but you've got to remember to actually subtract 2 from the number of sides. Okay, so there you go. You've got two different ways of getting the same result. 180 times by the number of sides, but then subtract the 360. Or n minus 2, subtract 2 from the number of sides first, times 180.